Academy Foundation presents the third law. The laws first describe the space of an object, the spatial effects of energy on the object, and now we can start the clock to see the equal and opposite changes across time. Here the water is reduced friction so the boat is more free to move opposite the person running. Equal and opposite isn't always this tidy, especially when kinetic energy and space-time definitions get involved. I left you holding a bag in the second law. It started with bubbles as an example of a group with uniform action forging a common identity with surface tension. Then I left you hanging on how kinetic energy is the causal mechanism of singularities and black holes. The presumptive heat creating singularity comes from angular momentum. Because the translation is angular, the common entropy effect is linear. Perturbation is a gauge theory term describing energy interfering into focus and confining its details in a material identity. This is like currents forming waves. Confinement is a chromodynamics term used to describe the strong interaction shaping space-time. Spaces and angular momentum by themselves are independent of time. Members of a group redistribute kinetic value in time toward equilibrium. That has an equal and opposite effect on discrete spaces defining the common identity independent of time. A bubble is a hypersurface made into a real surface by the accumulation of molecules over its surface. It is a spatial element created as an equal and opposite effect to temporal redistribution of energy. Hard or soft, it encloses the identity. Particles bounce off each other and exchange energy and direction. Celestial objects merge or break apart, but generally the shaping of their group spaces is based on charge interactions, forming vast electromagnetic fields that will focus the newly forming singularity at the center. These fields pass through toroidal phases. Local fields like Earth's north and south are dipolar. Solar systems forming into galaxies are quadrupolar. Remember from the first two laws that values forming a space have to go through hypersphere contexts. That means we systematically evolve a value into a surface that is then wrapped as a function of time to a volume. In a way, we have to pick a direction to wrap the surface to the volume. Quadrupoles can be wrapped relative to one charge direction or the other depending on the input shape. Our presumption is a plane of input made by wrapping the surface around the equator. It is the easiest way to show the virial theorem effects. It describes basic spiral galaxies like Andromeda. The Milky Way is a bar spiral. The hypersurface is wrapped over the volume relative to the poles. To get this requires a sort of vortex-like shaping. The Crab Nebula pulsar is similar to a bar spiral. Aside from having a degenerate density neutron star at its center, it has a vortex directly feeding the singularity until the available volume fills and is excluded as a ring. Solar systems in the Milky Way are set on end to revolve like the cabs of a Ferris wheel. They always have the same intergalactic view. They aren't spiraling toward the center of the galaxy. They are spiraling through the revolution around the center of the galaxy. The added twist makes what would be angular momentum evaluate as linear. The hypersurface is then defined by angular value and imperfect mirroring of the presumptive form. Chiral is the proper term to describe an imperfect mirroring effect, which is precisely the nature of the third law. The singularity represents the whole. It does not rotate relative to the parts. The parts revolve relative to the singularity. Whichever way the hypersurface is defined, its event horizon is at the one-sphere radius. The Schwarzschild radius is the two-sphere application to the volume potential that light bends around. The two-sphere is the temporal context of the one-sphere. Accretion is where the objects forming the singularity push mass across the event horizon. This artist's depiction starts fine with loose matter of a star being ripped from it across the horizon. Spaghettification interprets this as space being stretched. The dilation change doesn't stretch a discrete space, it changes the scale relative to that space, so loose things are pulled away. Solar systems or binary systems like this can easily lose one member to the event horizon, while the other gets catapulted out of harm's way. Coming up to the event horizon is exactly like falling. As they say, it isn't the fall that gets you. It's the sudden change in direction. The change in direction is specifically how space is being defined. The event horizon is perfectly termed because this is where the nature of your space changes. You are mass up to this point. Suddenly you are standing energy inside the volume because your redistribution went out of time and into space. As standing energy, it cannot propagate without being mixed. Eventually, the perturbing momentum becomes uniform, then contracts until other effects and limits of spacetime can cause a quasar effect. At the point of uniformity, the roles reverse. Things aren't pushed in anymore. They are pushed around into a dense elliptical shape. The only value that can be added into the volume of the singularity is entropy. Entropy then mixes the standing energy into light and particles that can now be pushed out. Gamma ray bursts are the easiest to observe. Bulk rings like the Crab Nebula are harder to see unless there are incidental light sources. At this point, we have to stop lest we jump into a whole other matter, namely that singularity is the universe's ideal right-handed generator. That means all its output is left-handed. Fleming's rules give us the fifth law. Just add electromagnetic field lines to complete Lyman alpha, showing hydrogen creation and asymmetric baryogenesis. Quantum relativity conceptualizes advanced topics in established physics to provide educational and practical tools. Our biggest problems in physics are human, specifically too much information and no accurate standardization of the concepts. Basically, advanced physics needs an introductory class to put it all together. Remember to subscribe and stay tuned for other educational videos. Thank you.